light blue speck sitting in this void at the hour of its send-off. NASA didn't understand that the Explorer mission would turn out to be one of the best space endeavors in history. The Explorer tests sent off during the 1970s have tenaciously noticed Earth, as well as everything inside our solar system and beyond. Despite having a memory limit 3 million times less than our cell phones and being multiple times more slow than our fastest 5G web connection, these surprising shuttles have furnished humanity with consistently new and astounding data about space. Now, Explorer 1 has made a frightening discovery inside the depths of interstellar space, provoking the government to make an unequivocal move by closing down this incredible mission. What exactly did Explorer 1 experience, and might we be close to an extraterrestrial intrusion? We should find out. The Apollo mission takes the spotlight for successfully handling the first humans on the Moon. However, there is without a doubt another remarkable mission that stands tall alongside Apollo, and that is the Explorer mission. This outstanding endeavor not only holds the record for the longest-lasting space mission but also has the distinction of being the first to investigate the outer planets of our solar system, from Jupiter to Saturn, Uranus, and Neptune. The Explorer tests, specifically, are viewed as the most promising for possible encounters with extraterrestrial life because of their thorough preparedness. Every Explorer rocket carries a remarkable golden record containing a collection of sounds, pictures, and greetings from Earth, serving as a depiction of humanity and displaying Earth's rich diversity, a gift that any potential extraterrestrial civilization could appreciate. But imagine a scenario in which these striking tests were to encounter a threatening extraterrestrial race. From the signals we are currently receiving, this is potentially what Explorer 1 needs to deal with at the moment. This chance has left researchers contemplating the potential outcomes, as such an encounter could prove more shocking than initially envisioned. Keep looking, as we will delve into the events that led to the government's decision to close down Explorer 1 and examine the potential consequences. But before we dive into those details, let's provide some significant context. On September 5, 1977, Explorer 1 set out on its space odyssey from Cape Canaveral in Florida. It was slung into space by the Titan IIIe Central rocket just a short time after its twin, Explorer 2, began its own heavenly endeavor on August 20, 1977. Their primary mission was to examine the enormous gas giants of our planetary system, specifically Jupiter and Saturn and their orbiting moons. However, these valiant voyagers surpassed all expectations by wandering deep into our vast cosmos, breaking various records along the way. They have outperformed all other spacecraft in longevity and have traveled farther from Earth than any human-made object. Incredibly, they even penetrated the boundary of interstellar space, venturing into unfamiliar domains of our universe. As of now, Explorer 1 and Explorer 2 dwell over 12 billion miles from our planet, consistently shocking researchers with their amazing revelations. Recently, they made an unexpected discovery that got the whole academic community buzzing. The Explorer twin tests have achieved phenomenal accomplishments. More than 40 years ago, they revealed the mysterious moons of Jupiter and Saturn, leaving researchers puzzled. These heavenly bodies were once viewed as dreary and hole-ridden, much like our own moon. However, Explorer uncovered their energetic and dynamic nature. In 1986, Explorer 2 became the first and sole spacecraft to wander into the realm of Uranus, quickly followed by an exhilarating encounter with Neptune just 3 years later. As these amazing spacecraft press forward with their inspiring odyssey, NASA has implemented smart measures to ensure their functional longevity by deactivating superfluous parts and heaters. Power is monitored, enabling the spacecraft to remain vigorous until at least 2030. The dedicated researchers and engineers behind the Explorer missions were shocked when an astounding discovery became known, so incredible that it prompted the government to intervene in one of NASA's most lofty activities. But before we examine that, let's discuss the reputation of the Explorer mission. Why is Explorer 1 such a significant milestone, and how has it changed our understanding of space? Among the ranks of famous missions like Apollo 11, the Hubble Space Telescope, Mars rovers, and the James Webb Space Telescope, the Great Explorer program remains a beacon of inspiration for future generations of scientists and space travelers. The data relayed by the explorers has yielded priceless insights, igniting countless scientific revelations and sparking the imaginations of researchers and space enthusiasts across ages. It's worth emphasizing that Explorer 1 and Explorer 2 were no ordinary rockets. They were meticulously crafted to function as stable platforms, with a rotation rate over 60 times slower than the hour hand of a clock. This careful design ensured minimal blurring of images and data as the spacecraft navigated through the vastness of space. Their remarkable imaging capabilities continue to astonish researchers and the general public alike. Indeed, even before their encounters with the outer planets during their journey toward Jupiter, they began transmitting images a while before reaching the gas giant. These initial pictures, exhibiting the swirling clouds and the famous Great Red Spot, filled NASA's Jet Propulsion Laboratory with pure delight. However, it was the discovery of dynamic volcanoes on Jupiter's moon Io that truly took the spotlight. Io, slightly larger than Earth's moon, emerged as the most volcanically active body in our entire solar system. The spacecraft's instruments detected unmistakable signals emanating from Io, and the vivid images they captured confirmed these remarkable discoveries. The pictures revealed towering volcanic plumes and a surface marked by the ejection of volcanic material. Remarkably, one of Io's prominent volcanoes erupted to heights exceeding Mount Everest by an astonishing multiple, covering an area nearly the size of France. Altogether, the Explorer spacecraft snapped over 33,000 pictures of Jupiter and its moons, revealing the planet's stunning beauty and the surprising diversity of the Jovian moonscapes. Before delving into the recent stunning discovery, it is essential to remember that the twin explorers have been unearthing a wealth of astonishing findings since their groundbreaking launch. One of the most amazing discoveries was the presence of Jupiter's rings, which, although faint, added an extra layer of intrigue to the epic gas giant. Additionally, Explorer 2 unveiled the icy shelf surrounding Europa, one of Jupiter's 53 named moons, estimated to have a thickness exceeding 60 miles. My recent discoveries tested long-held suppositions about far-off heavenly bodies, starting a restored enthusiasm in examining the likely tenability of cold moons. As the explorers bid an affectionate goodbye to Jupiter, they appreciatively received a gravity assist that offered them a fundamental lift, pushing them toward the captivating domain of Saturn. Without this cunning move, their escape from the Sun's gravitational pull and their ensuing journey into the profundities of space would never have been conceivable. Thus, Explorer 1 and Explorer 2 embarked on isolated directions, each wandering toward unknown outskirts, anxiously looking for new wonders to unwind. Explorer 1 took a path that brought it close to Saturn's moon Titan, which is encircled by a cloudy orange atmosphere. Researchers became charmed by the mysteries surrounding this moon, inciting them to conduct further studies on its complicated science. Explorer 1 then headed in a different direction, traveling north and creating distance from the plane of the planets, starting its exceptional excursion past the limits of our planetary system. In the meantime, Explorer 2 set out on a thrilling series of adventures that conveyed it to the outer planets of our cosmic neighborhood. In 1986, it achieved a memorable milestone by flying by Uranus, where it unexpectedly found 10 previously unknown moons, expanding the moon count of this planet. After 3 years, Explorer 2 arrived at Neptune, uncovering the phenomenal attributes of this far-off ice giant. During its encounter with Neptune, the spacecraft recorded wind velocities of up to 1,000 miles per hour, marking the fastest winds ever observed on a planet within our solar system. By zooming within 2,980 miles of Neptune's methane atmosphere, Explorer 2 provided unmatched insights into this distant world. Triton, Neptune's largest moon, turned out to be one of the coldest places in our solar system, with surface temperatures plummeting to a frigid -391 degrees Fahrenheit. Triton also exhibited unique characteristics, such as ice volcanoes ejecting nitrogen gas and icy particles up to 5 meters high into its thin atmosphere. These revelations expanded our understanding of the wonderful variety and complexity of celestial bodies, stretching even to the farthest reaches of our cosmic domain. One person who played a vital role in extending the missions beyond their initial targets was the esteemed astronomer Carl Sagan. As a member of the Voyager mission's imaging team, he energetically advocated for capturing one last set of images before deactivating the cameras on both spacecraft. These images would serve as a memento to humankind, providing a final look at our home planet from the distant depths of space. Sagan's persistence paid off on Valentine's Day in 1990, when Voyager 1 turned its camera back toward the inner solar system and took a series of 60 photos. The most notable of these images, known as the pale blue dot, remains an extraordinary symbol of our place in the universe, captured from a staggering distance of 3.8 billion miles. Earth appears as a tiny pale blue speck, scarcely visible in the vast expanse of space. This mission has been ongoing for almost 50 years, leading many to compare it to later space missions. One such mission that has made remarkable scientific contributions is the James Webb Space Telescope, JWST. Although their goals and scopes differ, both endeavors have pushed the limits of human knowledge and expanded our understanding of the universe. The Voyager spacecraft, Voyager 1 and Voyager 2, have been at the forefront of space exploration. These spacecraft continue to operate today, sending valuable data back to Earth. In contrast, the JWST, launched in 2021, marks the beginning of a new era in space observatories. It is a massive telescope optimized for infrared observations, focusing on the formation of stars and galaxies, as well as the atmospheres of exoplanets. By observing in the infrared range, the JWST will uncover hidden cosmic phenomena and provide remarkable clarity in our exploration of the universe. Both missions have pushed the boundaries of engineering and technological advancements. The Voyager spacecraft were wonders of their time, equipped with state-of-the-art instruments and systems that allowed them to withstand harsh conditions and maintain communication with Earth over vast distances. Similarly, the JWST combines advanced technologies, such as a deployable sun shield to protect its delicate instruments from the sun's heat, and a large segmented mirror to capture faint infrared signals. While the Voyager program focuses on our local cosmic neighborhood, the JWST aims to unravel the mysteries of the universe on a broader scale. Its advanced capabilities will enable scientists to peer back in time, observing the earliest galaxies and shedding light on the formation and evolution of our cosmic environment. What strategies were utilized to ensure the success of the Voyager missions? Imagine, almost 50 years ago, in August and September 1977, NASA embarked on a mission that would forever change our understanding of the universe. With steadfast determination, they launched a pair of robots into the infinity of space, equipped with a revolutionary technique known as gravity assist.
These moves would demonstrate to be vital, opening the secrets of the planetary system and moving humankind into the domain of the unknown. Picture this, an infinite expressive dance where the spacecraft effortlessly embraced the gravitational forces of the strong planets, harnessing their power to speed toward their intended objectives. Rather than depending exclusively on their own engines, the explorers exquisitely used the colossal force of these divine giants to slingshot themselves across the grandiose stage. It was a stroke of genius, a clever move that saved valuable fuel and propelled the shuttle with extraordinary speed, empowering them to embark on an exceptional grand tour of the solar system. At the core of this method lies the idea of gravity assist, also known as the gravitational slingshot. As Voyager 1 drew closer to Jupiter, a glorious gas giant with a gravitational power that defies comprehension, it required fastidious accuracy to coordinate the perfect encounter. Guided with extreme attention to detail, Voyager 1 effortlessly swung around Jupiter, harnessing its gravitational pull to accelerate the spacecraft with an explosive burst of speed, an invaluable oomph that pushed it further into the depths of space. Yet executing such a maneuver demanded an extraordinary level of expertise. A single mistake in Voyager's approach to Jupiter might have spelled disaster, jeopardizing the entire mission. The level of accuracy required was nothing short of remarkable. Nevertheless, the brilliant minds at NASA's Jet Propulsion Laboratory adapted to the situation, orchestrating these divine ballet performances not just once, but numerous times. These gravity assists became the driving force behind the incredible odyssey of Voyager 1 and Voyager 2 through our neighborhood of planets. Consider the fantastic accomplishments made possible by these slingshot maneuvers. Voyager 2, propelled by gravity assists from Jupiter and Saturn, set off on a daring journey to Uranus and Neptune, completing the magnificent Grand Tour. It was a victory of human resourcefulness and exploration, owing a vast debt to the accuracy and finesse of these gravity assists. Voyager 1, boldly wandering into interstellar space, was closely followed by Voyager 2, both propelled by the astronomical pushes given by these maneuvers. The concept of gravity assist might seem deceptively simple, but its execution is a testament to the brilliance and commitment of the people behind these missions. The grand tour undertaken by Voyager 2 demanded meticulous accuracy. Missing even a single slingshot could have meant catastrophe for the mission. Yet with relentless determination, these pioneers of exploration pushed the limits of what humankind could achieve, driven by an insatiable hunger for knowledge and a passionate longing to unravel the mysteries of the universe. While the gravity assist maneuvers played a critical role in navigating the cosmos during the Voyager missions, they were not alone in ensuring the success of these ambitious undertakings. Enter the Deep Space Network, DSN, a lifeline connecting us to our fearless Voyager probes as they ventured into unknown regions. Consider it the Interstellar Communication Network, a tapestry of enormous radio antennas strategically positioned across the globe. These fantastic dishes, ranging from 26 to an impressive 70 meters in diameter, served as vast signals, enabling essential communication with the spacecraft far beyond our planet. Imagine the Voyager missions as a grand odyssey propelled by an extraordinary curiosity that transcends existence, the 8-track tape. This noteworthy artifact serves as a massive time capsule, housing significant scientific data as it journeys through the immensity of the universe. Unlike standard consumer cartridges, the 8-track tape recorders used on the Voyager probes were a marvel of engineering, featuring a genuine two-reel storage system designed by Lockheed and manufactured by RCA. These remarkable machines boasted specific specifications. They utilized a belt-driven system and housed a 1.76-foot, 0.54-meter, long reel of 12-inch, 30.48 centimeters, wide magnetic tape with 8 separate tracks for recording data. These recorders offered versatility and accuracy, with recording speeds that included options of 1,150, 52 kbps, and 72 kilobits per second, while playback speeds ranged from a maximum of 576 kilobits per second to slower options of 336, 216, and 72 kilobits per second. The reliance on these outstanding 8-track recording devices within the Voyager mission represents humankind's unwavering commitment to scientific exploration. As these probes venture deeper into the universe, the enduring legacy of this timeless artifact continues to preserve and disseminate our insatiable thirst for knowledge. The Voyager missions have ignited wonder in all of us, pushing us to explore the vastness of interstellar space. Yet, before we delve into the discoveries that led to the end of Voyager 1, we must look at other fascinating interstellar missions: Pioneer 10, Pioneer 11, and New Horizons. These missions have played a significant role in advancing our understanding of the universe and pushing the boundaries of human exploration.